Hello world, Michael here. I'm now ready to give you our next batch of test results. I've done a lot of testing and I have learned a lot. I've learned a lot about the servers, about how to test them. I've learned about what to look at for performance metrics. I used to focus on CPU and I was, optimizing the code for that. Now I'm testing larger servers and I'm optimizing for network to reduce the packets per second coming out of the servers. And so that's been interesting. I've finally added 2 optimizations that I've been waiting on, and I had the reason to, now that we're getting into larger clusters. One optimization is called exponential decay, and that's where the further you are away from an avatar, the fewer updates you'll get. The update frequency will be lower. And so that's nice. It lowers the amount of updates you need. We still have exponential growth with messages the more players you add to the system. We still have exponential growth, but now it's just a smaller rate of growth, Exponential decay helped a lot. The other optimization that I've just added is coalescing messages into a single network packet. So instead of sending one message per every network packet to the client, I'm now sending anywhere from 1 to 10 messages. And so that helps. It reduces the packets per second that the servers need to service the same number of clients. But having said all that, it does introduce a little bit of a complexity with calculating what we really need to handle a given client load. So now it's a little bit more squishy, and I don't like to do fancy math. Someone else can do that. So because of exponential decay, it gets a little bit complex. If you've got an 8 chunk square area, and you want to calculate what 1,000 players in that area are going to need, that takes math. And I don't want to do math. I don't like it. I like to program. So now what I'm going to be giving you is the server test results. And we'll put them on screen, but I'll give you the number of servers and then the aggregate message handling rate of that given number of servers. That aggregate rate is what's important because it will give game designers, game developers, what they need to know to work with. Because the rates you need for any given genre are going to just vary based on what the game designers are trying to do. The first-person shooters are going to need a higher message rate per client, and then something like a turn-based RPG won't need as many as a first-person shooter. And so by giving this aggregate message rate, I think I can give people a better grid for what the servers can handle, because they can take that information and then figure that out, what it means for their genre, for their specific type of game. Invariably, it's really good because the message rates are very high. And the point of this whole thing is that we can scale our servers to handle anything. And I have still found that to be true. I've tested up to 50 servers and found no ceiling. I think there is a ceiling, and I'll get to that in a minute. I just don't know what it is. I mean, it could be at 1,000 servers for all I know. Anyway, let me give you the test results real quick. For a 5-server cluster, I use 1,850 of my simulated clients. Those clients are doing 10 hertz updates with exponential decay. And so that 5-server cluster seemed to handle about 16 million messages per second, and which averages to about 3.2 million per server, a little bit more than that. A 10-server cluster handled 2,250 clients and could do what I'm thinking is about 30 million. I didn't test it all the way up to 100% CPU. I think it can do about 30 million at least. And that's an average of at least, 2.9 million per server. A 20-server cluster could handle 3,000 clients and do well over 53 million aggregate messages per second. And that's about 2.6, 2.7 million messages per server. If you're keeping track, I'm looking at the per server rates decreasing. I'll get to that in a minute. Finally, the big test I did was 50 servers, got up to 50. That cluster could handle over 4,700 clients, all sending full 10 hertz updates with exponential decay and the message aggregation. That cluster handled 150 million messages per second, which is a little bit over 2.8 million, maybe 2.9 million messages per server. So if you keep track of all that, there's a little bit of a decay when it comes to the per server rates. Generally, that's a bad thing, but I think I know what's going on here. I have a theory about it. My current theory is that, as you would expect, as the size of the cluster increases, there's a lot of peer-to-peer traffic going on between servers. And so the larger the cluster, the more server-to-server communication there is. And I think that just adds up enough to where it's now measurable on the client side, causing a reduction in per server rates. That's actually fine. And at the rate it's decreasing, if it is in fact decreasing, because kind of went up with the 50 server guy, If it is decreasing, that means there is some sort of ceiling to what the technology can handle at this point. You know, that's my theory, and it's good because I think I can solve that completely. I can remove the server to server communication from the hot path of the server to client communication, and I can scale it out separately. And so that's what I'm working on now. So I think I can get rid of that completely. In theory, like even if I don't, I think this shows that our servers can handle a lot of message traffic, and that's really good. That's what we're trying to prove. But I'm working on a big rewrite right now that includes actually a lot of other big optimizations with scaling out servers per threads and all that. So I think my next test, I'll do the 50 cluster test again, hoping to get a lot more, but then I'll go bigger. I'd like to get to 1 billion messages per second. These kinds of tests get expensive, but you know, it's part of the process, right? They consume a lot of bandwidth, and largely bandwidth is what we're paying for the most for the cloud computing costs. And that's what games will be paying for when they use the service. They'll be largely looking at bandwidth costs as their primary cost of using our replication cluster. Okay, so where does that leave us? Basically, the big news is that we've got a 50 server cluster that can do 150 million messages per second and no end in sight, really. Probably go to 100 just fine, 150, 200, and scale to what anyone needs. And here's the thing. I'm giving you these quotes. You know, this is the number of servers and this is the number of clients they can handle. The client thing is just density. You got to keep that in mind. We're not talking about game population. The maps can handle any number of clients, kind of unlimited population. The data that I've given you is all about density within an 8-chunk radius. And those are the numbers that you're hearing. The 50 server cluster did 4,700, a little bit more than that. That's 4,700 players in an 8-chunk radius. That's amazing. And that's in a map with unlimited density. So you can have that 4,700 people in that 8-chunk area and then go to the next 8-chunk area and have another 4,700 people just fine. And it all works. So we've got some amazing technology. It's going to let game designers make games that we've never imagined before. Virtual worlds with no limits. It's going to be amazing. So we got GDC coming up in a couple weeks. I'll be going to that. This is the first time that we'll be doing a walk and talk with other, game studios about our technology. We haven't been very aggressive with reaching out to game studios because we've been developing the technology. We need it tested, blah, blah, blah. People need to know it works. We're making demos right now. We're making sample games. You can actually still download and play it. Not much is going on there. I mean, it's not like a game. But yeah, it's happening. We're making the demo games. So now going to GDC, this will be the first time talking shop with people. I expect to get a lot of pushback on whether this is even possible, that we've actually been able to do what we're saying that we can do. So I expect a lot of pushback and disbelief, and that's fine. This environment has kind of like dug its own, not grave, but definitely dug its own hole, saying you can do single shard, like real single shard with no limits. That's scam territory. And I would expect nothing but skepticism from especially people with technical backgrounds that know how challenging this actually is. Nonetheless, I'm still very excited to go to San Francisco, talk shop with the industry, and see what level of interest there is. So that's happening in a couple weeks. So my next video will probably be after that, and I'll give you an update on how GDC went. I think that's all I had to give you guys. I'm very optimistic with these results. Honestly, I should take a step back. These are amazing results. Being able to put together 50 servers that work together and send 150 million packets a second or 150 million messages a second, that's really awesome. And it's all low latency, and game designers are going to be able to build amazing things on top of such a thing. And it's inexpensive, really. All things being equal, it's quite cheap to do this. Taking a step back, looking at it, we deserve a pat on the back for getting this far. It's very exciting to have this technology this close to being ready for production and usage. So there's my testing update. Next update, bigger cluster, more optimizations, and hopefully we'll be showing absolutely no diminishing return on the per server rates. And, maybe I'll get a little pushy and spin up a ginormous cluster of servers just to see what does it take to get to 1 billion messages per second and even further. So thanks for tuning in, guys. Thank you to all of you who have subscribed and have been following us on the various platforms. It's very important. It's really cool because this technology could be a revolution. And I just like the idea that you're in this early, watching it, because we've all been hoping for this in one form or another. There's been various Kickstarters, various projects in the past that have tried to do true single shard. If we can pull this off, this is revolutionary. The biggest revolution in online gaming since online gaming. if we pull this off. All right, I'll leave you with that. Thanks, guys. See ya.